The responsibilities of IT are constantly evolving. Ethernet, VoIP, mobile, and now streaming video. And while video seems to be everywhere, from smartphones to tablets to car dashboards, few resources are available answering basic questions like, how can I stream professional quality audio and video on my network? There are a number of advantages for running AV across your network, and we'll focus on two of the leading protocols: CobraNet, which supports audio streaming only, and audio-video bridging, or AVB, which is designed for both audio and video streams. Historically, AV connections were one-way and point-to-point. This connection model resulted in large, confusing masses of cables, which drove up both material and labor costs. Using a facility's existing structured cabling was seen as a way to reduce installation expenses and increase system flexibility. But the problem then became how to effectively transmit digital AV signal over Ethernet, because streaming professional audio and video requires a deterministic network with consistently low delay. Protocols that use data compression, such as VoIP, aren't suitable candidates because professional audio and video use a much higher bit rate and require a much lower latency. Also needed are tight synchronization between multiple channels for proper lip sync and audio localization, as well as efficient bandwidth utilization. CobraNet was one of the first Ethernet-based protocols to offer a solution for many of these issues, partly because it introduced a precise network-wide time base, which is not native to Ethernet. Developed about 15 years ago, CobraNet is a proprietary protocol designed to deliver uncompressed, multi-channel, low-latency digital audio using standard Ethernet packets. But instead of TCP/IP packets, CobraNet uses data link layer packets to transfer data because they're not as susceptible to the latency and QoS problems commonly found in higher layer protocols. CobraNet can only be used on a local area network since it's not an IP-based protocol and cannot travel through routers. And it's fairly typical to put a CobraNet network on its own VLAN for the purposes of maintaining QoS. With CobraNet networked audio, any audio input can be dynamically sent to any combination of audio outputs on the network via software commands, providing excellent signal routing flexibility. CobraNet does not require special hardware, and you can use existing switches that are 100 megabits per second or faster. CobraNet is designed to handle a maximum of 32 input and 32 output channels for a total of 64 channels. While this is well suited for many applications, larger venues and installations need to carefully consider channel count as well as latency when designing a system. Latency over CobraNet is at least 1 1/3 milliseconds per network hop, which for some applications can be unacceptable, especially when combined with further delays resulting from propagation time and digital signal processing. AVB was developed to provide an answer for installations that require lower latency and higher channel counts. An AVB network implements a set of protocols ratified by an IEEE task group. And because it's not proprietary, AVB provides for greater interoperability between devices. In fact, an industry coalition called the AVNU Alliance was formed to ensure AVB interoperability of networked AV devices, helping to provide the highest quality AV streaming experience. Similar to CobraNet, AVB is not an IP-based protocol and can only be used on a local area network. There are three primary pillars of AVB architecture: precise time synchronization, making it possible for multiple devices to process audio and/or video in sync in a standard way; resource reservation, sometimes referred to as admission controls, to ensure that the requested bandwidth of streams is allocated; and traffic shaping, which evenly distributes the stream over time to prevent packets from transmitting in bursts. These pillars make it possible in many cases to have latency of less than a millisecond over multiple hops in a 100 megabit network. And AVB has the capacity to transmit up to 420 digital audio input and 420 audio output channels, up to 840 channels total. AVB requires smart switches, which will route AVB streams and maintain QoS requirements automatically. While this may require you to invest in new switches for your network, the smart switches require less programming and administration by IT, which makes them simpler and more cost-effective to manage. While CobraNet and AVB are both excellent for transmitting digital audio over a network, every installation has unique requirements, and you may want to consider some of these differentiating factors for your next installation. If you have additional questions, please call us at the number on the screen or visit us on the web at biamp.com.